All right, guys. Very good morning, very good evening. Uh, yeah, let's begin with the today's demo session two.
Good morning,
Before,
Mati.
very good morning. Before that, anyone has any questions or queries? I'm happy to take it up, or else I can proceed with the as planned demo topics for today. All right. Quick recap. Um, the first thing is what we discussed yesterday about course topics, course content, and the course timing and the course curriculum
Malik,
and the fee structure.
I'm sorry for the disruption. Could you please introduce about yourself?
Yeah, that's great. Like yesterday we did that very beginning of the course.
I'm sorry I missed it. I joined late, 5 minutes late.
Okay, not an issue. I'm gonna share that demo session with everyone. Probably you can go through that again. I'm always happy to share about myself. Uh, I'm a B graduated in electronics and communication and started with my career as a Oracle DBA. Uh, and then I'm having around 13 years of experience in this Oracle field. I worked in various organizations, starting with iGate and Oracle Corporation and EXA group of companies and some of the consultant jobs. And then currently I'm working with Rubrik. I worked with various roles, started with the software engineer, senior software engineer, lead, team lead, and infrastructure lead, right? So these are like various positions I held so far. And the major activities which accomplished by me was for one of the customer, we built entire data center. And for one customer, we migrated their entire data center from uh, New Jersey to Washington, DC. So these are like two major projects what we accomplished in my career. Apart from that, there are so many activities like, rack setup, DR setup, and Golden Gate setup, EBS implementation. Uh, those are like so many other tasks we have completed, and I'm certified with most of the Oracle product. I worked in various Oracle product with Oracle uh, various versions, starting with 9i, 10G, 11G, 12C, 19C, and 21C, and then uh, other Oracle product where I was certified and worked was Oracle Exadata, Oracle Golden Gate, Oracle EBS apps, Oracle PeopleSoft, and Oracle OBI. And also I worked in engineering systems like Exadata, Supercluster, Exalogic, patching, implementation, and migration, and all those things I worked. And also certified with Oracle Cloud. Uh, Having said that, Oracle is my primary domain, and I willing to learn in Oracle. I willing to stay back in Oracle domain, and that is not restricting me to explore my knowledge. I am also certified with AWS. I'm also certified with Informatica. I worked with the Informatica, uh, Erwin Design, Informatica data modeling, and also I worked with MS SQL database. I also worked in a Postgres DB2. These are like my sub skills, other skills I can say, but my primary skills or focus is purely based on Oracle. Right. So that's about my overall experience considering the IT. All right. All right, guys. So that's just an intro on me. There's some more things. Probably tomorrow we are coming on live. I'm coming on live um, to share my Oracle ACE journey. That's one of the other achievement where last year I got Oracle ACE award from Oracle. I'm going to talk about this Oracle ACE journey, and I'm going to talk about my entire career journey along with my some of the YouTube celebrations. So I'm coming live on that. Probably you can ask any questions and answers. There are a lot of questions and answers. A lot of questions are asked in my LinkedIn and personally one-to-one on my WhatsApp. Probably I listed out everything. I'm gonna take up all those questions. Probably I can clarify everything during the live session tomorrow. I'm coming on live on my YouTube channel. Hope you guys see you over there. All right. Let's come to the topic here. We started with the uh, um, you know understanding of database course and all the topics whatever going to cover in this particular course, and also the importance about this course, who can attend this course, and what is the course timing, and what is the course fees. Everything we are covered in our yesterday's topic. And also a little bit understanding of ASM and basics of database, and then how the data center uh, resides, where the data center resides, and then how as a DBA, we are going to access those servers. Either it may be Linux or it may be Windows, whether it's a physical server or a virtual box, we are going to connect remotely, because your data center somewhere in your remote areas like London, Washington DC, New York, or wherever your data center, all your servers are going to reside over there. So we are not gonna go into data center and access the server. Everything we are going to access remotely. So basically for Linux, we are going to use Putty and MobiXterm and some other tools. These are like Putty and MobiXterm are widely used. And for Windows, we're going to use remote desktop connection. So these are the two methods we're going to connect remotely and access our databases. Right. So assuming that our databases are in London data center, and we have my Linux server in London data center, and we got access on our London data center. And then as a DBA, we'll start with the installation. So first thing is your Linux admin, right? So he is going to install VM. So it may be VM or it may be physical server. In your data center, he is going to install a VM virtual machine or the physical server. Again, many people who are newcomers or fresher, they will get confused with what is VM, what is physical server. Physical server are the servers physically resides in your data center with all the memory, RAM, resource, hardware, all the processor, everything will be like physically resides in your data center. That are called physical servers. And virtual servers, virtual machines, VMs are nothing but on the top of the physical server, on the top of physical hardware, they're gonna spin up n number of VMs. For example, I have one physical server which has uh, like 100 terabyte of storage, 100 terabyte of RAM, and then uh, 1 terabyte of CPUs, and then thousands of cores. So that is called the blade servers. So on top of those servers, we're gonna spin up small VMs with a 10 GB RAM, 100 GB hard disk, 2 GB core, 2 GB two cores and two CPUs. Like you can spin up your VMs. So those are called VMs. So these VMs you can spin up on top of the physical hardware server, or you can spin up on any of the cloud machines in your AWS or Azure or Oracle Cloud. If you have a cloud subscription, you can spin up your own VM over there. Again, same concept. Any cloud provider, they will be having a physical hardware server, and on top of that, you're going to spin up the VM. So just understand VM means you are going to spin up a small virtual machine on top of a underlining physical hardware. That's a simple meaning of VM. Right. So your Linux admin is going to install VM, and or he is going to install a physical server, and then he is going to create user ID for you. Right. He's going to create a user ID for you. And then once he create a user ID, he can share the IP address of that VM or a physical server, and he's going to share your user ID, and he's going to share your password. So yesterday we saw that how to create a user on Linux server. Your Linux admin will do that one. And then he's going to share the IP address or the host name for that particular VM. Right. So the moment he shares IP address or the host name with a user ID and password, so we can use either a putty session, or we can use either MobiXterm, and then we can connect. So for example, if I go to putty session, I'll be installed it on my laptop or wherever the workstation. I'll be installing my putty session, or I'll be installing my MobiXterm. So I'll just click on MobiXterm and then click on new session, and then I'm going to take SSH. I'm going to go ahead and then use the IP address, whatever the IP address my Linux admin has provided. So I can put it here. This is one of the IP address. So I'm just going to take this IP address, and then I'm gonna use that IP address or the host name. I'll connect to that server. right? So it's going to ask me username. I can say username at be your individual username or the root username. Root is a master user, like admin user for any Linux server. And then you might be having your own individual ID, or you may be having root user password, or you will be having your own user ID and password or root username and password. I'll just connect with the root username and then the password, right? So I'm able to connect to my VM or the physical server, which is remotely resides in my data center, any data center, right? Right. So that's your Linux admin part. So installing your VM and installing the physical server on your data center and creating your user ID has been done by your Linux admin. Once your server is ready, and then second step is as a DBA, we download softwares. We download software called, first thing is we're going to software ASM, that's a grid infrastructure software. Grid infrastructure software, I can say. So one is grid infrastructure software. If you're using ASM, again, yesterday we talked about ASM or non-ASM, right? ASM is a storage provider. Oracle strongly recommends to use ASM as your storage layer to store your data files or store your database, right? So you're always supposed to use ASM as a storage, and many organizations, they may or they may not use ASM based upon their needs, right? So if you are using ASM, you download ASM software that's called grid infrastructure software, and you're gonna download.
అంటే లైనెక్స్ యూస్ చేస్తాను.
Sorry guys. Guys, if you are not talking, just go on a mute so that it will not be disturbing others. The first thing is we're gonna download ASM software and we're going to install ASM home. That's called grid infrastructure home. And we're gonna download Oracle software and we're going to install so that's called ASM, stands for ASM Automatic Storage Management. That's called Grid Infrastructure Software, and we can call it as a Grid Home as well. All right, and then we're going to download Oracle software, and we're going to install it, and we can call it as a Oracle. This is Oracle software, like you can say Oracle software, and then we're going to install that Oracle software. Once we install that Oracle software, it will be act as a Oracle home. Right, and then the third step is once ASM is ready, once database home is ready, we're going to create a database. Right, so we're going to create a database. And again, this is optional, guys. Right, so this step is optional. I have Linux or I have Linux server, VM or a physical server. I can directly install Oracle software and I can create a database. I have a physical server or virtual box. First thing is I can install ASM. On top of that ASM, I can install Oracle home, and then on top of that, I'm going to create database. So it left to you whether you're going to use ASM or you're not going to use ASM based upon your need. Right. Again, question is where you are going to download these softwares, ASM softwares and Oracle softwares. It is from Oracle eDelivery. So from Oracle eDelivery, you can go ahead and then register with your Gmail ID, and then you can download the software that I have showed you in our yesterday's class, right? You can log in with your Gmail ID to Oracle. Let me show you one more time. And then you can easily download it, and then you can use them for any educational purpose. So if I can open my browser here, I can go ahead and search Oracle eDelivery. And then very first thing is your software delivery cloud, Oracle software delivery cloud. And then you can create with your own ID with the Gmail account, and then you can sign in, and then you can download your software, whatever software you want. Right. So
what is the relevance of ASM, and in which use case we're gonna give a preference to ASM?
Yeah, there'll be a separate topic we're going to cover on ASM. And also yesterday we just briefed on ASM, why we need ASM. If I can show you one more time and I can explain you here. Where is that one? Okay, here. So we have separate chapter for ASM. ASM stands for Automatic Storage Management. And this is a simple slide how you are going to understand software stack with ASM and without ASM. So this is typically your file system without ASM, and this is typically your databases with ASM. So if you see, you have ASM layer here. You have operating system, and you have operating system, and then on top of that operating system, you're going to install ASM, and then on top of ASM, you're going to create your databases. Once the moment you create database, your databases will be residing under ASM. ASM will act as a storage mediator for your databases. And then in this case here, your databases, your underlying database is going to store under your OS file system, whatever the operating system file system, it may be NFS, SAN or NAS, your database is going to store under file system. So this file system is managed by your operating system. So there's a logical value manager comes with your operating system, and then that logical value manager is going to manage your file system. So your database has to communicate with your file system via logical manager, via operating system, and anything, any application, like anyone from connected from application side to my database, and then any read data, any write data, it has to communicate with the file system via logical value manager here. So again, that is also provided solution by Oracle. This is also supported, but your database is going to involve your logical value manager. Oh, that's a mediator. And in this case here, we are not going to use any of the file system. We're not going to use any of the logical value manager. Your ASM will act as a logical value manager. Your ASM will act as a file system, and anybody connected to application via application to database, that database will directly access, read, write data from ASM. So ASM is a Oracle provided software, and database is also Oracle provided software. These two will act very brilliantly. Your IO access will be much more faster than this IO access. This particular database has to access from the OS file system. And here in this case, your database is directly access data from your ASM storage. So accessing data from ASM is very, very much more faster than accessing data from database to your local file system. That's where always Oracle recommend to go with the ASM as a storage rather than your local file system. Right? That's one of the advantages. And there are much more advantages for ASM will be covered as part of ASM class here. So these are like few advantages. It is high performance. Accessing IO from your database to ASM is a high performance, and Oracle will manages the data files with the naming convention, and all those things will be managed by Oracle itself. And also it has some more feature called ACFS, called automatic, that's ASM cluster file system. That's ACFS. There's a other feature or advantages of ASM, and it spreads data across the disks, like balances the data, and it mirrors the data, and also it is solves the storage challenges. So these are like many advantages of if you use ASM.
ASM is basically forming a cluster within the system and performing a load balancing over there for the Oracle data.
ASM has many advantages. Like if you use it for the cluster, it will act as a cluster. If you don't use it as a cluster, if you use it only standalone, it will act as a storage. ASM will provide you cluster feasibility, cluster feature, and also ASM will provide you a storage feature, and also ASM will provide you a load balancing, data load balancing, and also ASM will provide you data mirroring. There are a lot of advantages. If you're talking about Oracle RAC, and ASM is mandatory.
Okay.
Right?
Thank you.
But that is optional. Like, Oracle strongly recommend to go with ASM, but if you go with ASM, that's well and good. If you don't go with ASM, and you can directly install your Oracle software, and then you can, install your database, and you can create your database. Right. This is my Oracle lab one, where there is no ASM. If I do ps-ef grep smon, and smon is like system monitor, which is going to list all my databases which are running on this server. This is my Oracle lab one. I have 5 databases are installed here, and all 5 databases are up and running here. And then there's no ASM running here. And if I connect to my one more server, I have one more server. If I can just connect on that. Right. So this is my Oracle Lab 2. And then where I have my ASM is installed here. If you see, this is my ASM. I installed ASM, and then this ASM is going to act as a storage mediator for my database here. Right. And then my database, this test CDB, test DB, both the databases going to store their data files inside my ASM. I showed you yesterday on this one, how the storage structure works here. And then on my Oracle Lab 1 here, I have these multiple databases. There is no ASM running here. So which indicates all these databases are going to store the data inside a file system. Right. So all those databases are going to store the data inside the file system. That's the OS file system. I'll just connect to one of the database. I'll take devdb.orinv. I'm going to set the environment for that database. I'm going to connect to database. I'm going to say list the data file, select name from $v data file. If you see all data files, your system, sysocs, undo, users, all are coming from your OS file system. This is your OS file system. Anything start with slash, that will be your OS file system. It may be SAN, NFS, NAS, or local storage. Everything is coming locally from that particular operating system. That's your local file system here, whatever you're seeing here. So if I go to other database here, if I connect to my Oracle and set the environment to any one database here, and SQL plus class as sysdba, I'm going to run the same command, select name from VDalert data file. So if you see anything start with this plus, that's your ASM storage, right? So your ASM will act as a storage provider for your database, right? Your database, all this database data DB1, DB2. In this case here, your database are test CDB and test DB. These two database, your data files are going to reside under ASM. That's the only identity, like, you can make it where your database is going to reside, ASM or storage. First thing is you can go ahead and check ps-ef grep smon whether your ASM is running or not. If ASM is not running, that's a local file system. If the ASM is running, that's your ASM storage. Your database are going to reside under ASM storage, right? So that's a simple thing. You can connect to database. You can check for your data files, where your data files are resides.
So how do you check if your ASM is running or not?
Yeah, same command, right? ps-ef grep smon, and that's going to indicate whether ASM is running or not. Right.
All
So
right,
yeah,
thank you.
again, these are like advanced concept. I'm going to just cover it briefly here. It'll be like separate topics will be covered. What I wanted to convey right now, once your VM or the physical server is ready, as a DBA, we'll get access to that server. Our Linux admin will provide username and password and the host name and IP address. We're going to connect to that. Once it connected, and then we're going to start with the downloading the software, Grid software, Oracle software, and then we're going to install Grid software and Oracle software. So if I exit, and then if I check, these are like I said, ASM and Oracle got installed. Where they got installed, I can simply check etc Ora tab. The moment I check etc Ora tab, this is the file it will get created moment you install your ASM and Oracle home. Cat etc Ora tab, the moment you check that one, you're going to see ASM, and then this is your ASM home, grid infrastructure home. So whatever I'm talking about, grid infrastructure software or grid home, where your ASM is running. So this is your ASM home. If I go and check here, ls, and then these are your grid infrastructure software. The moment you install your grid infrastructure ASM home, all the software provided by Oracle are installed over here. All the binaries, libraries, executable, 64-bit, 34-bit, all those like all the binaries will be available inside your grid home. And the respective other database will be installed here. Like, this is your Oracle home. Oracle software is installed here. Use your own app, Oracle product 19C DB home 1. If I go into that DB home 1 ls, so this is your Oracle software, all the Oracle binaries, executable libraries, your Java files, 32-bit, 64-bit, all the binaries for your Oracle home are installed here. Your grid home are installed here. Once you install these binaries, and your database will up and run perfectly fine. If you delete any of the binaries here in this particular folder, your database will go down. Your database, whatever this database up and running, so for this database, your Oracle binaries are supporting. In order to up and run this particular database, your software, whatever you installed, are pretty much supporting these databases or this ASM. If anything you do wrong on this particular Oracle binary, eventually your database and your ASM will go down. So we never ever touch anything inside my Oracle home or anything under my grid home. Right. So those are the software we installed as part of our course, right? Like, once we start our regular course, I'll just connect. That will be like our first step. We're going to install it once we start our regular course. If I go here, right? So we'll be start with installing 19C software, installing your Oracle home, grid home, and creating your databases, manual method, silent mode, GUI mode, all those things will be covered as this chapter number 3, 4, 5. Right. This is simple understanding how your server will be built by your Linux admin. Once you get access on that Linux server as a DBA, how we are going to download the software and how we are going to install my grid and install my database home. Once we create grid home and Oracle home, and the rest of the things will be like create your database. Right. So you can create, like if I say I created 1, 2, 3, 4, 5, I created 5 database here. And here I created 1, 2 databases. You can create n number of databases on a server. There's no restriction at all on that. As long as you have enough CPU, RAM, storage, you can create n number of database on that server. There's no restriction at all on that. Right. So that's your other part. The moment you create a database. Right. Once you create a database, that's done. Your setup is ready.
Both ASM and Oracle home is you install using Oracle user only, right?
It is left to you. You can install ASM with some different user, Oracle with some different user. Many customer I have seen it with Oracle user, you can install both ASM and grid, or you can go with a separate ASM. You can go with a grid user. Oracle, you can go with the Oracle user. It is left to you how you can design, but there is no restriction on that.
But what is the best practice, industrial practice?
Again, there's best practice. If you talk, majority of customer, they will go with a different user. ASM, they will go with the ASM user called grid or Oracle grid or whatever the name. For Oracle, you can go with now Oracle user or Oracle DB or Oracle database or whatever the name you can create. You can go with a separate user for your grid and database. I've seen it many customers mix match.
And I think we need to create some this group. These users need to be attached to some groups now, permissions and all.
Right, that will be covered once we start with the installation. So that will be part of actual course where we're going to.
Okay.
Sorry about that, guys. Okay, it will be covered once we start our actual classes. How we are going to create the user, how we are going to create the groups. So those will be like covered. Just to touch base on that, if you brought that, I can. There's a separate lab as part of this installation. So will be covered. The labs are attached over here in this particular PPT. The moment you open this lab 2, and then in that lab we'll be covering on that. What are the groups we are going to create? What are the users we are going to create it? Will be covered as actual implementation. And what are the memory? What's the minimum requirement? All those things will be covered. Right.
Malik, I have a query with regards to file system creation. Could I ask?
Yeah.
Say for example, if I request Linux admin to create a file system, who has to provide the VGS name and the LV name? Should we provide or they should?
No, everything will be provided by your Linux admin.
Okay.
We never ever use or deal with LVs or VGs or nothing.
Okay.
We just need a mount point.
Okay. Thank you.
Malik,
Alright.
what is the difference between grid and databases?
Right. So your ASM grid, there's nothing special about grid. Your ASM is also instance. Like if I go here, ASM is an instance. Your database is also instance. And your ASM will run for ASM software. Your database will run for database software. Database software, we can call it as a Oracle home. ASM software, we can call it as a grid home. That's a simple understanding. The people will say grid and the people will say cluster, where the people will say ASM. Nothing. Your ASM instance will start from grid home and your Oracle instance will start from your Oracle home. That's a simple understanding. We can cover more on that once we start the class. What is grid and what is clusterware? But simple understanding, grid means your ASM home and Oracle home for your databases. Right?
Okay.
Right, sir. Does ACM hold a specific version that needs to be compatible with the Oracle version we are installing? Or
Your ASM should be always higher, and you can go with any version of database. Your ASM suppose 19C, and your database should go maximum of 19C equal to your ASM. And you can have any lower version for your database. Your ASM is 19C. Your database can go with 19C or 12C or 11G or 10G or whatever the minimum version you can go with that.
Is there a compatibility metric that can be referenced in case required, in case we're using a lower version of ACM?
Yeah, there's a compatibility in Oracle support document. We
Okay.
can always refer that. Right. Okay. Is that clear? Like, this is the overall installation process what we cover as part of our course, right? Like we'll start with ASM, we'll start with database installation, and we'll create a database. Once the database is ready, and then we'll set the environment and we'll connect to database. Right. So if I quickly draw that one, right, I can just differentiate here. Like this is my Oracle Lab 1. Right. So this is my Oracle Lab 1, and where I installed my DevDB. Since in order to create this DevDB database, what I did, I installed my database software here, U01 19C DB home _1. Right. So this is my database home. I installed first. Once I installed my database home, I created my DevDB, and then I can access my DevDB here. This is typical my Oracle Lab 1. This is typical my Oracle Lab 1, where I created my DevDB, and then my DevDB is installed on this particular Oracle home. So actually the Oracle home is different here. If I can check one more time, cat etc Oracle tab. Cat etc Oracle tab is the one you have to check for this Oracle home. So I have DevDB, and this is my Oracle home. This is my actual Oracle home, but I just give an example U01 19C DB home 1. So if you want actual Oracle home, this is your actual Oracle home. So this is a typical installation for the standalone without ASM. If I can go with my other lab, Oracle Lab 2, Oracle Lab 2. So this is my Oracle Lab 2. What I did first, I installed plus ASM. So I installed my ASM under U01 19C and grid. Right. And then on top of that, I have created my database. My database name test CDB. And then this particular database, whatever I created on top of my Oracle home. So my Oracle home will be U01 19C DB home _1. I'm just giving just a dummy example here. But if I can go to actual server and then check, this is my grid home. whatever grid home I mentioned. This is my grid home here. And then this is my DB home. Right, so this is your typical installation here, your DB and your TestDB. So database is equivalent to same and your Oracle home is equal to same. Only extra part what comes here is your ASM grid software. Yes, we can call it as the ASM software or the grid software or your grid infrastructure home or your clusterware home. They can call it as many names, but all are same. ASM and its home. That's it. Simple understanding. Right. So this extra portion will come into picture, the installation part. If I remove this one, this and this are going to be same, right? That's the only difference between your with ASM and without ASM. If that is clear, why we need this ASM, and without ASM also I can able to run my database, and then what's the advantage of ASM? I told ASM will act as a storage provider, and your database, whatever is going to access the data from ASM is much more faster. Your data will be like distributed equally, and your IOs, input output, data accessing and data write will be much more faster. Right, and then also mirroring, striping, all those features will be available with ASM. That's where this is always recommended by Oracle. Always use ASM. On top of there is one more advantages of using ASM. I'll tell you what that is. Assuming that it's a mid of the night and your server crashed. This is whatever this Oracle lab on, it is crashed due to some network issue or due to some OS issue. Your server rebooted. Server went down. The moment server goes down, your database will go down. Obviously, right? Whatever running inside that server, everything will go down. And then after 5 minutes, your server is back online. And then will your database comes online automatically? No. Assuming that if it's the mid of the night, you have to log in, you have to connect to server, you have to start your database. That's all manual effort. And assuming that your Oracle Lab 2 went down, again, due to network issue or OS issue, your server went down. After 5-10 minutes, your server is back online. Again, it's a mid of the night. The moment your Oracle Lab 2 comes online, this particular ASM has a built-in brilliant feature called HAS, High Availability Service. What that HAS means, the moment your server back online, your ASM will automatically starts. No need to start. No DBA need to wake up midnight and then start your ASM. Your ASM will automatically brings up as the OS comes online. The moment your OS Oracle Lab 2 comes online, your ASM will automatically starts, because that's a built-in functionality with ASM. That's called HS, Oracle High Availability Service. Your ASM will come online. Since your ASM comes online, ASM is already aware of what all databases running under that, and automatically your ASM will bring your database here, right? So no DBA intervention needed here. Automatically all your ASM, all your database, everything comes online. That is because of your HAS, Oracle High Availability Service, right? So that's where, that's one other advantages of using your ASM, right? So no need of any DBA intervention whenever there's a server reboot or whenever there's a network issue or server issue. When the server reboots, obviously DBA, no need to worry at all, because it automatically brings, right? So that's a major advantage of ASM. On top of those storage and your logical value manager, mirroring, striping, ACFS, with all those features, with a high input output, this Oracle restart also is one of the major advantages of ASM, auto restart, right? That's a simple understanding between ASM and non-ASM, right? So if that is clear, any questions on that with ASM or without ASM or the
Yeah,
storage?
funny here. Malik, see, we have an instance where server got rebooted, but the instance will not come up. Now only ASM will come up. That any other configuration is required for that?
No.
Because
If it,
I'm also working under DB only, but See, I have seen situations like ASM only used to come up, and we used to manually bring up the instance and all.
No, there's the options. You can disable your database. SRVCTL disable your
Yes.
database. The
Ah.
moment you disable your database, it will not come up automatically. Check it whether they have disabled your database auto start. And I can show you here one live example. Just see here. This is your database, right? TestDB, PS-EF grep smon TestDB. I'm going to kill this. Kill -9. Kill your database. So PS-EF grep smon. Your database is gone now, right? Your test CDB database is gone. I have only one database. Wait for another 10 seconds. Your database will be back online. Right? You can see your database is back online. So your ASM has a intelligent mechanism. What all databases are installed with me? It's my job to bring it up the moment it goes down. And I'll go to here, lab 1. And then this is my DevDB. I'm going to kill that one. Kill -9. Down. Your DB is down. DevDB is down. And it'll never come back. Your DevDB is gone. DevDB, we have left with only 4 DB. You can wait for 1 day, 2 days. It'll never come back. Manually, we need to start that database. Because there's no ASM here. It's all DBA manual intervention needed here. Right? It'll never come back. So I need to connect to my database and I need to start my database. DevDB, SQL plus, /s DBA. And it says connected to idle instance, means nothing is running, it's idle. So I need to do start up my database. And then my DevDB will be back online. Right? So that's a simple understanding why Oracle strongly recommend to use ASM. Right? The moment you kill here, and your ASM is smart enough to bring that online. Yeah, automatically brought here.
Okay, so we need to do configuration CRS level, na? CRS or SRV?
SRVCTL.
SRVCTL.
Yeah. All right. That's a understanding of ASM and database. And now we can quickly cover some more basic stuff. What exactly? Many people will often say database server, instance, and data files. And then people often get confused what exactly mean by database and database server and what is actual server. This all one and same. I'm going to clarify a few doubts here. Let's go back here.
Malik,
Yeah.
Balaji here. Sorry for the interruption. Like when the server is rebooted, there is an option in the ORATA file, right? Like why if you set it to why the database will come online automatically.
No, it will not come online. You have to write some OS level script to bring it up.
Okay. Because
even if you make no, that will not work out. If you say N or Y,
yes.
it will not work out. Even if your OS reboots, it will not come automatically. You have to write some OS level scripting, and you have to include that.
Okay. Then what is the purpose of Y and N?
I have written some in my blog. I have written some article long back.
Okay.
DB start and DB shutdown automation. For this one, your Y and N will be useful. Like, if you mention Y and if you mention N, like for example, I verified here, and if you mention it as a Y here, I can directly go to my Oracle home bin. I can just run the DB start. The moment I start the DB start and the moment I run the DB shutdown, automatically to bring down and bring up.
Okay.
Right. So for that, you can use that Y and N. If you see here, log file, Oracle home, the moment I shut down DB shutdown, Oracle home, both my database will shut it down here. Right. So that for that, you can use that one.
Okay.
Right.
Okay.
All right. Let's remove this one. Let's go down here. Okay, just to correlate, right? There's a human being and somebody gives some instruction. Okay, can you remember this particular address? Or somebody comes to me and then tell, okay, one of my friend comes or my manager comes Can you note it down this particular IP address? Can you note it down this particular database details? And then what I can say, immediately any instruction comes to me, I can remember in my mind for a time being. And then eventually after some times, I may forget that, right? And then I'm gonna write into notepad or any book. And then once few more information comes from my manager or from my anybody like neighbors or whatever, like as a human being, if I compare my database server, the instruction will be keep on coming. My friends, colleagues, or relatives, or whatever my work environment, whatever they will tell to me, I'll be keep remembering in my mind. And then eventually I may forget those things over the period of time. So just to avoid that, I'll start writing into notepad. And then once the notepad is full, I'm going to take new book and I'm start writing into the new book, right? And then after certain days, again, my manager comes back. I given you some IP addresses for this particular database. Can you give me that? If I remember that IP address, I can easily immediately tell him, okay, this is your IP address. This is what you told me long back. And then if I don't remember, I can go back to my books and then I can fetch the details and then I can give it back to him. That's how we human being will work, right? The same scenario at your database level also. So at your database, if I say this is my database, and then I have something called instance, and then I have something called database. I can correlate on this particular Oracle Lab 1, PS-EF grep smon. Whatever you are seeing here, these are called instances. Your instances. Whatever on the OS level, the moment you do process list, smon, pmon, whatever you do, these are all your instances. We have an instance called devdb. That's what I mentioned here. devdb is my instance. And then that instance has memory plus background process. If you see here, I connected to my database here, what are NV, devdb, SQL plus SSDB. The moment I do start my database, it's going to assign the memory here, bunch of memory here, right? Variable size, buffer size, redo size. Like these are the memory, it will assign it to that instance, right? That's the first thing. And then the process will get started. These are the processes. Like if I do ps-ef grep devdb. So these are your processes. For example, devdb, we have bunch of processes. If you see, right, these are the processes we can see for each database. Processes will be available for my databases, and then memory will be get assigned the moment we start the instance. And that's the first thing. Somebody will ask, what is instance? Instance is nothing but combination of memory plus background process. Any database you start, you're going to start the instance. The moment you start the instance, it'll assign the memory and it'll start the background processes. Right? That's your simple definition. Instance means is nothing but memory plus background process. Like your human being, whatever this human is equivalent to your instance. Instance is a one, like, from me, for me as a human, if any instruction reads and writes to the notebook has to go through me only. So similarly, if somebody want to access my data, or application team want to access my data, or end users or business users want to access the data, they had to go through instance. Whatever the applications, they will first connect to instance, and via instance, they will access the data. Right? Instance is nothing but memory plus background process. How this human has some memory and then the pair of hands to write or read the operation. Similarly, your instance also has the memory plus background processes. Right, there are many memory component we can talk as part of our architecture once we start. Just understand we have some memory, like we have SGA, PGA, your SAID full, large pool, Java pool, DB buffer cache, redo buffer cache. There are a lot of memory component we'll talk in our actual course, but for time being now understand instance is the one which is going to start at my server, whatever the database server, whatever the host, on that host, we're going to start my instance. These are instances, right? These are the instances. We're going to start the instances. Those instances are nothing but memory plus background processes. So the moment you start the instance, it's going to assign bunch of memory, and these are your background processes, process IDs, right? These are your background processes, right?
So each database has a separate instance with can run on the same server?
Right. That's correct. Each database will have its own separate instance. These are instances. Right. So if somebody, your application team or end users or business, do some select statement. For example, I can say one user connected, user one, client one connected to my instance. They will connect to instance. They will not connect to database. Again, assume guys, database is nothing but your actual data files, right? Like if I can go back again here, if I can connect to my database, select name from $v data file. So the moment I run $v data files, these are my actual data files where all the end users or the application users or the business users, all the tables, view, synonym, whatever the data, whatever the table they will create, all will come and reside under my data files. This is called your actual data files or actual database. So if I can go into this particular location, right? So these are your data files. Data files are nothing but your database. You can see data files or the storage files or the database. All are same. Database means your data files where your end user data is going to reside. Your instance is nothing but memory plus background process. The client one, assume that he created a table T1. This particular table T1 is going to reside under this particular database or the data file. I can say data file. Right? So the T1 table is going to reside under these data files. And then if you want to access, read the data, he has to connect to instance, and that instance will connect to my database, and then it's going to fetch that result, and then that will give it back to that user. That's the read process. If this client is, again, there's a client too, and he's going to insert some data, he's given some data, and then he'll give that instruction to instance. Instance will connect to my database, and then he will write the data into my database, and then it will come back to that user. Okay, write is completed. So any transactions are going to happen. Everything has to happen at my instance level. If my instance is down, nobody can able to access data. Right? That's a simple understanding. Instance is a
Hello, Malik.
Yep.
Malik, if you create your database, how many files will be created?
The default is these 4 data files: syssoc, system, undo, and users. Again, we'll talk about that the data files as part of our actual course. Don't worry about which data files, what is the importance of syssoc, system, temp, undo, users. Each of one data file has its own significance, and then will be covered with the actual course. But right now you can assume these all are your database. Database is means combination of all of your data files. That is your database. Right? So anything like how this user, any read operation, any write operation, he's going to write into notebook. Similarly, any read operation, write operation on my instance is going to read into my or write into my data files. Right? And then if somebody asks the same data, instance is going to access the data from my database and then give it back to that user. That is a simple understanding of your instance and the database correlation. Right? And coming to that question, is there any limit of number of data files? I said these are number of data files here. Like right now I have 5 data files here. Is there any limit on those number of data files? Similarly, if you can correlate here, whatever this user is going to write into this book, if this book is full, he will get one more book. Is there any limit on this particular books? No limit. Similarly, in this particular data files, there's no limit. You can have n number of data files, 1,000, 10,000, right? So you can have n number of data files. Right now, dummy database just had a 5 data files here. You can create 10, 100, 1,000 data files. Is there any limit to each data files? That's important. So I can create 1,000 data files, right? These data files having very less size now here, 99 MB, 600 MB, 1 GB. So is there any limit on this particular data files? Yes, there is a limit. Each data file can go to 32 GB, 64 GB, and then again, we'll cover that on what basis we're going to define that limit on the data file size. While creating a database, you're going to limit that how much maximum my data file can grow, 32 GB, 64 GB, 100 GB, 120 GB. That can be decided while creating your database, right? So these are the second question, like, is there any limit on each data files? Yes, there's a limit on data files, but there's no limit on number of data files. Is there any limit on size of database? Obviously, if there is no limit on number of data files, there's no limit on the size of database. You can grow your database as big as you can. 10 terabyte, 20 terabyte, 100 terabyte. You can grow your database as big as you want. You can, right? Right. That's about simple understanding. Any questions on this?
Does instance and database has to reside on the same server? Is it mandatory?
That is I'm going to cover here next slide.
Okay.
Right. That's your next question.
Sorry, Malik. See, I mean, there is a limit, right? I mean, as long as the memory is available, only we can fill the data. No.
Again, like this is your own restriction, not from the Oracle side.
For example, 500 GB data.
No,
file
that's
is
what, like, again, it is your restriction on your server side. And if your server, as long as it has enough memory, RAM, CPU, storage, you can go as big as you can.
Okay.
Talk about Oracle's perspective. There's no restriction from Oracle side. It's a restriction from your OS side. If your OS has only 100 GB storage, you cannot go more than 100 GB. You have to increase your OS storage and you can create number of data files again.
Okay. No. This ASM and all will be assigning some learn and all, no? That based on the storage availability only, no?
Again, ASM or storage, it is limitation from your side, your OS side, not from the database side.
Okay.
Right? You think in that perspective. Your OS is full and you cannot create any more data files. You have to increase your OS storage and create a new data files. That's a simple understanding.
Okay, fine.
Right. So, yeah.
Who is gonna write these data files?
Again, like will be covered as part of your our actual course. Again, as I said, like this human has a pair of hands who is going to write the data into books. Similarly, your background processes. There's a DB writer, log writer, check pointer, SMON, PMON. Those processes will do all these activities. For your questions, there's a processor called DB writer. DB writer is going to be responsible for writing the data. And there's a process called your server process, which is going to be responsible for the read the data and give it back to that user. And similarly, there are many processes: DB writer, log writer, check pointer, SMON, PMON. Each of those processes will have a particular task. Right? You can see for now, your processor, background processes are responsible for writing, reading, and managing your database.
Okay.
Right. Coming to the standalone, I'll give you just differences already covered in yesterday's topic. I have one server here and one database instance will be running. That database instance is associated to my particular database. Database means, again, guys, your data files. One database instance pointing to one database files, one-to-one mapping. And second database instance has its own data files. That's a database, one-to-one mapping. This is standalone. If this particular server goes down, your instance will go down. Your instance will go down means nobody can able to access your data. And whereas in rack, I have server 1, server 2, server 3, where my instance 1, instance 2, instance 3 will be running. For all of these instances, your database will be stored under your storage, shared storage. Your data files, your database will be under common storage. All three servers will be accessing the same storage. And if this particular server goes down, we have a server 2 and 3 where you can still access your database, your data files. That's a rack, high availability. One server goes down, you have other servers to access the data. Here in this case, one server goes down, you don't have any option to access this data. Right? That's the difference between your rack versus non-rack. And here, guys, somebody asked the question, right? How many database instance I can install? How many database servers we can install on a server? Like they will call it as a database server. If I can go back to my previous slide. Right. So this combination, they will call it as a database server. Like this is your instance. Instance is nothing but memory plus background process. Database is nothing but actual data files. Actual data files are called database. This database plus your instance is called database server. You can see Oracle database server, not the server. If your actual server means your OS, if you call it as a database server, it means combination of your instance plus database called a database server. Again, people will get confused. Database server is equal to server. All right, whatever this Linux one, they will call it as here. Like, if I can say Oracle Lab 1 is a actual your VM, your physical server or a VM server, virtual box. This is your OS server. And what is database server? Database server is nothing but your instance plus your storage, wherever the data files are resides. Combining together, they will call it as sometimes database servers. Right? People often get confused with what is database server. Database server is nothing but combination of your instance plus your data files or your database or your storage files. That is that's your database server. Right. The first question is how many database servers? How many database servers? Database servers means how many databases I can install in one server. Right. I showed you example here, 2 instances, 2 database servers. Can I create third one, instance 3 and database 3? Can I create a fourth one, instance 4 and database 4? Can I create that? Yes, you can create. You can create n number of instances and n number of databases. As long as this particular server, whatever this server you are seeing here, has enough memory, RAM, CPU, storage, you can create n number of instances, n number of databases. There's no restriction at all. Right? You should have enough memory on that server in order to create. If I do free-g and I have 11 GB in this particular Linux server, I can create a 3 GB, 3 GB, 3 GB, 3 databases. I can create 2 GB, 2 GB, 2 GB, 10 databases. I can create 1 GB, 1 GB, 1 GB, 10 databases or 11 databases, right? As long as the server has enough memory, RAM, CPU, and storage, there is no restriction at all. You can create n number of databases, n number of instances on a server, right? Can I have an instance and different server, instance and database on different server?
Excuse me, for each instance, we need to create different databases.
That's part of your database creation. The moment, right, wait a second here. The moment you create your database here, if you see the third step, the moment you create your database here, it's going to create its own instance. It's going to create its own database. Again, database means what? Data files, right? The moment you create a database, as part of the database creation, it's going to create its separate instance. It's going to create its separate database. Database is nothing but data files. It's part of your database creation. You don't need to worry on that, right?
Okay.
Right. Again, question comes, can I have an instance and database on different servers? Yes, you can have it.
We can have it.
Right now, if I say this is my instance, DB, which is running under this Oracle lab. And if I run the data files, these are my data files. If I go here, right? So these all are like data files, locally available. My database instance, my data files are locally available on this server. And then I can ask my Linux admin, can you mount one separate mount point from any other server? He can do NFS mount point, and you can create your database on that NFS mount point. Your database instance will be on your Oracle Lab 1, and your storage will be coming from your other server, right? The storage may be local storage, or storage may be your NFS, SAN, NAS, or some other server. It may be coming from anywhere. That's so I'm going to use it as a storage for my database or storage for my data files, right? Answer to this question is yes. You can have your instance on server A, and you can create your database, that's your data files, on a different server. But the point here is you have to mount those mount points here on the server. Without mounting that mount point, you cannot access, right? So you have to mount that as a NFS mount point on the server where your instance is running. You can create database or the data file on the different server, but only thing is you have to mount it as a NFS mount point or the SAN mount point or the NAS mount point. It should be available on that particular server as a mount point so that you can go ahead and create database files on that server.
So can we install ASM in a different server and DB in a different server?
That is called Flex ASM, available starting with the 19C. Till
Okay.
before 19C, it is not possible. Starting with the 19C, it is available. That's called a Flex cluster. Your ASM will be running on instance 1, your database will be running on instance 2 and 3.
Okay. Can we cover that?
No, that's a rack. It will not be on this. That only available is a rack. In the rack, there's called Flex. It will be available starting with 19C. Right. So last question is multiple databases pointing to single instance. For example, I have database 1, DevDB. I have a database 2, TestDB. These two databases can be point to one instance. No. Answer is no. Again, right? Just think it. The moment you create your database, it's gonna default create one instance and it will tag to its respective database, respective data files. It's like one-to-one mapping, as I say, like one instance, one database. And here in this case, I have DevDB, TestDB. Can I map to one instance? No. For example, if I can go back PWD and this particular directory, I have multiple databases here. I have TestCDB, DevDB, two databases. Can I access my DevDB? Can I access my TestDB using one instance? Like, I can say this is my one instance. DevDB is one instance. It will always default registered with my database, that is DevDB. With this DevDB instance, can I access my TestDB data files? No, it's not possible. It's always one-to-one mapping. Remember in Oracle, one instance map to one database. Multiple database cannot map to single instance. It's a part of your database creation. The moment you create a database, default one instance will be created for the database and default the data files will be created for the database. That like one-to-one mapping always in Oracle. Right? So multiple database, single instance is not possible, but multiple instances, single database is possible in rack. If you see multiple instances, instance 1, instance 2, instance 3, map to one single database, a DevDB database. So that's your rack feature. Multiple instances map to one single database, but multiple databases cannot map to single instance. That's not possible. Right? Any questions on this? All right. With that, we can quickly cover one more topic and we can close it for today. I'll skip this now. Okay, this is simple understanding.
Malik, sorry to interrupt. Multiple instance we can create, you said, no? So the same DB version will be created in multiple instances, right? We cannot have different versions.
No.
For example, 19C software is installed. So we will have only 19C database only. If we want some 12C means we have to go for some other server only, right?
You can install like here, you can install 19C software, you can install 12C software, you can create one 19C instance, you can create one 12C instance. There's no restriction. All are running from its own separate home.
Possible in the same server.
In the same server, yes, it's possible. Right? Because those instances will run for that particular home. We're not disturbing others.
You did not explain about servers.
You did not explain about servers. Servers is your own VMs. Whatever that your Linux admin is going to create, that's your servers. That's the physical servers or the VMs where you are going to create your database instances, right? And this is my servers. Oracle Lab 1 is my server. Oracle Lab 2 is my server. That's your VM. That's your physical server, the Linux box. And inside that, we're going to create the instances.
ASM also a server?
ASM is not a server. Like server is your OS.
Okay.
Inside that, we're going to create a database servers. Database servers means databases or database instances. And ASM is not a database server. ASM is an instance which does not have any files. It's just a mediator, right? Like again, don't get confused with ASM and database. Database is the one actually used for your industry to store the data, to retrieve the data. I already explained ASM will act as just a mediator, or ASM will just act as a storage provider for your database.
Like ASM? Sorry,
Yeah.
like instance.
Like instance, this is just an instance which will act as a mediator to provide a support to your database as a storage. There is no data files for your ASM. Like, if I connect to my database and then check for the data files here, right? Select name from with the data files. I can see my data files for my database. And the same thing, if I connect to my ASM and check, there won't be any data files for ASM because this is not the database. This is just an instance, act as a mediator for your database to provide the storage. So if I connect to my ASM, if I run the same command, whatever I ran here, ASM will not have any data file. ASM, first of all, will not be in open mode. It says database is not in open mode. Database not in mount mode. ASM is just like instance, which will like act as a provider. Like, if you can just correlate here, your ASM will not be having this data structure. ASM will be having just an instance. Right, that's a understanding.
How do database aware of ASM? Is there any configuration or by default?
The moment you create a database, will be registered with your ASM. For example, there's a command called crstl stat resource-t, and you can see your test CDB registered with your ASM. And then whatever the database you create, those database will get registered with your ASM. So if it is not registered, no, it's a part of your database creation. The moment you create database, it will automatically get registered with your ASM. And if it is not registered, we can register it manually. Right, so that's a understanding, like, your ASM will take care of. It's a part of your database creation. Will default get registered with your ASM. If not, then there's a manual method to register it, and you can deregister also. Great.
Hello, sir.
Yep.
Hello, sir. This is what is the shared server and the dedicated server?
Again, that will be covered as part of the course. We'll be covering here dedicated server and shared server. Again, that's a different concept. We'll cover it once we start the actual course. It's a part of your database installation. While installation of your database, you have an option to create as a dedicated server, or you have option to create it as a shared server. Right, dedicated is kind of one-to-one mapping, and shared server is like one-to-many mapping. So we'll talk it once we start the actual class. Right, that's a type of database creation. Right.
So,
Any questions?
how to start and stop ASM services?
Same thing. You can do shutdown, start again. It'll be part of ASM. Will be covered that. If I can simply show you that in a minute. Where is that one? ASM is here. There are many methods for your ASM. Okay, that one. Okay, here.
Might
Okay.
be we are in a grid user, right?
Right. So in order to start and stop your ASM, you can connect SQL plus assist ASM, and then you can do startup, and you can do shutdown. That's one way. And then the second way is sructl start ASM, sructl stop ASM, the second way. And then the third way is connect to your ASM command line, startup, shutdown abort. For ASM, there's a many method to shutdown and startup. You can use them. Right?
So ASM CMD, before we are connecting like ASM CMD, so Oracle user is fine or grid user only we have?
Grid user. If it is installed with the grid user, you have to use a grid user. If installed with Oracle, you have to go with the respective owner. You have to go. You have to just do a ps-ef grep smon, and you have to log in with that respective owner. You have to do this ps-ef grep smon, this database running with Oracle user, this ASM running with Oracle user. You have to log into that user. If this ASM running with the grid user, you have to log in with the grid. You have to check this one, ps-ef, who is the owner of that. This is the owner. Right.
Malik, what does actually CRS-CTL and SRS-CTL mean? And we use only in ASM, right?
Only in ASM both are supported, CRS-CTL and SRS-CTL.
Actually, how we call that SRS-CTL full form like?
SRS-CTL is a cluster control utility. CRS-CTL is server control utility. For ASM to manage, we're going to use CRS-CTL. For database to manage, we're going to use SRS-CTL. But again, will be covered in details once we start our actual class. But right now, CRS-CTL is a cluster control utility. SRS-CTL is a server control utility. So manage your database, we're going to use SRS-CTL. To manage your cluster or ASM, we're going to use CRS-CTL. All right. Any questions? Right. This is a simple a 3-tier architecture. Again, in industry, everyone will follow the 3-tier architecture. That's the best practice. Meaning that it will be having a different layers, like front end, middle tier, and the back end. You can call it as a front end or a client or a web or a mobile or the presentation layer. You can call it as any layer. That's a front end layer or the presentation layer. And the middle layer is like middle tier, middleware, app server or web server, anything you can call it here. That's a middle layer. And the backend or the database tier or the data management tier, that's a backend layer. These are like 3-tier architecture. Any application in industry they're going to design, it will be 3-tier architecture. That's the best practice. From the front end, your end users or your business users or the clients, they can access using a web URL, or they can access using a mobile device, or they can access with the desktop or the client or whatever it is. Whatever the mode, they will access to your application. That request will go to application server. That application server might be your EBS, OBI, PeopleSoft, or any banking application. It may be Apache, web server, or Tomcat, whatever it is, middle layer. It will go to that application server. From that application server, the connection will go to your database. But will go to that database server, and then it's going to connect to that instance. From the instance, it's going to connect to that data files. And if it's a select request, we'll fetch the data and then give it back to them. If it's an insert, it's going to connect to the database, it'll insert the data, right? So this is like standalone. Standalone, like only one instance, all the connection will go to that instance, and then they're going to connect to that particular database data files. If this instance goes down, right? Or if that server where your instance is running, if that server goes down or the instance goes down, all the applications will be down. None of the users are able to connect to your database. Downtime, complete downtime. Whereas in case of rack, if the client will be connecting from any mode, URL or mobile or desktop, all the request will go to application. From the application, connection will go to instance 1, instance 2, or instance 3. If you have a 3-node rack, 4-node rack, any one of the instance, it will go, connection will go to that. And then via that instance, they're going to access to my database, shared storage. It will be on the shared storage. Your database or data files will be on the shared storage. Everyone will be accessing the same data. If this instance goes down, or the server where this instance is running, that server goes down, automatically whatever the users are connected here, it will automatically fail over to any one of the node here. And then that user will not be aware whatever the instance he connected is failed or shut down, and his connection has failed over to any other instance. This user will not be aware. That is called high availability, Oracle TAF, transparent application failover. In case of rack, whatever the user connected, if that instance goes down because of some issues, automatically the connection will be failed over to any other nodes. That's one of the advantages of rack, right? So this is a simple understanding how in industry the application deployment will work, and that's a comparison between the standalone versus rack. Right. So any questions so far? I'm going to stop it here for now because
Malik, can you go back to that previous slide?
Yep.
Yeah. I mean, this is on rack actually. See, you said like the application owner, request this rack DB, right? And result will come back once the data is fetched. I have one small question here. if he application owner, fires a, insert query or a select query, and it reached a rack database. By the time, so I understand that there will be some dedicated server process will be created, no, between application and the DB.
Right.
So in middle, if the, a node one, node one, or it is running on node one, so that goes down. So data will be fetched to application owner, but how it will happen here?
Means I did not get your question. Come again.
See, for example, some select query or insert query, application owner has triggered. So a server process will reach the DB. So by the time it returns the value, power goes down. Instance goes down.
Right.
So how that will?
Right. No, the moment instance goes down, we have something called TAF, transparent application failover, the process in your rack cluster. And the moment this connection goes down, automatically whatever this connection, it will be re-established to this particular instance here. And the new server process will be started on this server here for this particular connection. And then whatever the data will be fetched from this instance 2, and then given to that end user.
Okay, for the same job, a new server process will be initiated, right?
Right. Obviously, it has to start on that instance.
Okay.
And then that new server process will give that result back to that end user. And provided if you connect something called TAF, transparent application failover, if you enable the TAF, then only it will work. Otherwise, it will not work.
It is DB level or application level?
It's a DB level, database level. You have to create the TAF, transparent application failover.
But here TAF only read operation, write operations means it's not work, right?
Write will not work, yes. Only read.
In case any insert command is going on, it will fail, right?
It will fail and he has to resubmit again. His session will be failed over. And his transaction say that transactions failed. He had to refire that query again. If it's an insert, update and delete. If it's a select, he no need to refire.
Half it inserts means that transaction will not get committed, na? Insert
Everything
will commit.
Everything will be rolled back.
Rolled back, okay.
Yeah. All right, I'll stop it here. Let's discuss if anyone has any questions, queries so far related to course or the topics or anything. Happy to address. Otherwise, we can close it for today.
Malik, as you said that in rack, one of the node gets down and it will take over by rest of the node. But what about the failed node? We have to create one more new, or how?
No, that is went down. Like why it went down? You have to do that RCA. What's the issue? And then you have to restart it automatically if it is not coming. And if it is automatically comes online, that's well and good. Otherwise, you have to start it manually, all the ASM databases, and you have to do that RCA on that. Why? What's the reason? What's the root cause for that?
I have one more question. As you said that instance and ASM both are similar. So when we create the database, by default it will create the instance also. Instance plus database inside that. So in that case, when we create ASM, in that case the database instance also it will create, or since
your ASM is not a database instance, it's just an instance. There's no data file for that. I already showed you, right? It's just an instance. And if you can connect and you can query for the data files, nothing. Your database instance just starts. Nothing. It will not go to mount. It will not go to open mode. Because no data file at all for that. Just an instance.
Use only for memory concept.
Just act as a mediator for your database to provide the storage feature for your database. All right.
Will this training target any particular certification?
No, you can complete after this course. You can pretty much go for OCA and OCP, or you can go for Admin 1 and Admin 2 19C certificate.
Malik, what is the process to stop and start resources in cluster?
Again, it depends. There's only two commands in cluster, srvctl and crvctl.
Okay.
And it depends upon which service or which process you are talking about. If you are
Like
talking about database, you're
yes.
talking about database services, then pretty much we use SRFCTL.
Yes, Malik. I'm talking about database, ASM, and listener. Like, say, if I want to stop the cluster first. So, I mean, if I want, I mean,
No,
if
again, like I said, right, there are only these are the two utilities in your cluster with SRFCTL and CRSCTL. And you can do bunch of commands with SRSCTL. You can do bunch of commands with the CRSCTL.
that's what, like, what should be, which one should be stopped first? Should I stop ASM or DB or which one cluster?
You no need to stop anything. The moment you stop your cluster, automatically cluster will take care of that. All your databases, all your listeners, everything will be taken care by your cluster. You no need to manually stop your services, manually stop your database, and then stop your cluster. That you no need to do. You can
Is
just
that
run.
command is like CRSCTL stop cluster or CRSCTL?
CRSCTL stop CRS and
Okay.
CRSCTL stop CRS-F.
Okay. Okay. Thank you.
Like, I have a small doubt. Regarding in real production level, we need to move a data file actually. So in 12C, we are using here 12C actually. So can we, what is that? Whether it is required for downtime to move data file in 12C?
12C is a new feature. You can move data file online. You don't need of downtime. In 11G, there's no online movement. You have to shut down.
Standby also is there, no? So that's what I want.
Standby, you no need to worry. Like automatically, if you set your data file, standby data file management equal to auto, automatically it will take care. There's a parameter in your production, standby file management. If it is set to auto, you no need to worry about your standby database. Automatically, it will take care of that.
So just I go that standby file management auto, and we have to move the data file online only in production level, right?
Right.
Yeah. Okay. Thank you.
Hey Malik, how do you know a database is a rack from OS level?
Okay, simple thing. The moment you do ps-ef grep smon and check it out whether your ASM is running or not. If ASM is not running, then it's not a rack database.
Oh, so automatically when you see ASM running, that means it's a rack system.
It is not necessarily rack system. That's one way. Like, you can check if no ASM, it means it's not a rack. And then there's other method. You can do srvctl config database -d and your database name. And then the moment you do srvctl config database, you're going to see the difference between your rack database. And then this is standalone. You don't see any rack options here. And then I'm going to show you one example for rack database. If I have one of the rack node here, I'll just get one of the server. Give me a second. Right. One other way, like most of the standard naming convention, I can tell you. Not here. Go to ps-ef grep smon. Okay, here, right? If you see VaraDB2, VaraDB3, VaraDB4, the instance naming convention will be like, if you see this particular slide, you're gonna see, suffixed with the instance number 1, 2, 3, like instance 1, instance 2, instance 3. That's one way.
Okay.
And there's other method like .varinv, and then you can set that environment and then srvctl config database -d and your database name, not an instance name, database name. And then you can see type of the database as a rack.
Rack. Oh, right. Okay.
And here, when you do srvctl config database, you don't see the type of the database. If it's a rack, you can see type of the database is rack. How many instances it has? It has instance 1 and instance 2. You can see database instances. It's a 2-node rack, and number of nodes are node 1 and node 2. It's a 2-node rack. And if it's not a rack, you don't see that nodes, you don't see that rack type and all those things.
All right, thank you. And secondly, in the course of the course, right? Are you going to show us how to create our own database server?
Yeah, well, that will be covered in Monday.
Okay, all right, okay.
How do we access CRS? How do we access CRS-ETL command? Well,
CRS-ETL.
yes.
That's at your cluster level. The moment you install your ASM,
Okay.
the cluster level is all set. You have to set your ASM home.
Okay.
And then you can run any CRS-ETL command.
Okay. No need to go to grid home and then run it. Could you please show it?
You have to set the environment to your ASM plus
Okay.
ASM. And then the moment you type it, you can run. You have to set the environment to ASM. The moment you set it with CRS-ETL, and you're going to see that running from your grid home.
Okay.
So you don't need to go inside that one. Just do CRS-ETL stat resource -t.
Okay. Okay.
You have to set the environment.
Malik, is there a difference between the instance name and the database name?
It is left to you. Default instance name and database name are same. And then if you want to change it, you can change it.
Oh, okay.
Right. If I can go here, one of the database. They're like, again, I'll cover as part of our course. Not only good topic you brought, there are many naming convention. One is instance name, database name, database unique name, and database global name, and then service name. These are the names, 5 naming convention for each database. And then I'm going to cover as part of the course, what are the significance. For example, if I connect to sysdba, any one database, show parameter name, I'll just go with the show parameter name. One is DB name, and one is DB unique name. Other one is a global name, and other one is instance name, and last one is your service. Instance name, DB unique name, global name, and service name. What are the significance when we are going to use? Most of the times, most of them are same, but when it comes to standby database, there's a slight difference with the DB unique name and DB name. So we're going to talk about that as part of our course. Right, in real words, all will be set to same. You can see DB name, global name, and service name, all are like set to same. Default, it's going to be same.
All right, thank you.
All right. Any last questions, guys?
Malik, this is Balaji. Like, if I'm, this is the same question. Just want to understand better. So when I'm asked to stop the services in, services in cluster rack database server, because before rebooting the server. So is it enough? I stop the CRS-ETL stop CRS, and to start CRS-ETL start CRS. That is it. That command should be fine, right?
All right. So for example, if you see, I have how many database? Like, my instance 2 here, ASM2. If I do .orinv plus ASM2, this is my rack cluster. If I do OLS nodes, and the moment I do OLS nodes, I have a 2-node rack. This is a 2-node rack, right?
Okay.
2-node rack. I need to type OLS node, node 1 and node 2. And then I'm connected to node 2 right now. And then in that, these many databases and services and listeners will be running. If I do, what happened? Okay. If I do ps-ef grep tns. So I have so many listeners, so many services are running here. The moment I do CRS-ETL stop CRS, and you can do -f. -f is for force. If you don't use -f, also fine. The moment you've done it, it'll automatically bring down all your listeners, all your services, all your databases, all your database instances. Everything will be down here. So you don't need to worry at all. The moment you start it, CRS-ETL start CRS, automatically all your listeners, services, everything will come online.
Okay.
I'm going to take few seconds, few minutes, because it has to shut down a lot of databases.
And this command should be accessed from as a root user, right?
Right. It's only root.
Okay. Thank you.
All right. So any more questions, queries, guys, before we wind up?
Sir, PDF notes available?
Yes. This is the only master PPT. We're going to use it throughout this course. And then each of this master PPT has its own own lab material attached to that. And then there's a workbook attached to that same PPT. If I can go here, you can go and download that. This is the workbook. If I can download that, and then in that workbook, everything will be like explained. If I can go here, give me a second. Right. So if I can open that one. Okay. So this particular workbook will be has all your commands, all your how we're gonna install and where you can download with all the screenshots. Everything will be like attached over here on this particular workbook. And then and if you get access on the Google Drive, in the Google Drive, there will be a lot of things. And let me bring it down here. Bring it here. So this is a Google Drive. Once you get access, and you have to go to that particular database course material, and then in that course material, you're going to see the PPTs, quiz, and then the course workbook, and then you're going to see lab exercise. All the lab exercise, whatever we're going to talk here, all the labs with the command. If I can open one of the lab here, all the commands, whatever we're going to cover, all those will be available here. So we're going to execute all the labs here, whatever listed out in this lab here. And there's a particular some extra document for related to DR and some of the ebooks, some of the Linux basics, some of the commands, and then some of the ebooks will be available on this particular folder. Yeah, there are a lot more here, and especially when you talk about RMN, there will be a lot of RMN scenarios. These are written by me, like a lot of RMN stuffs. Like when you talk about RMN restore and recoveries, there'll be like plenty of scenarios listed out here. Everything will be like written, and then you can just need to practice all of them. Right, will be covered as part of this course. Demo, everything will be shown, live examples, and then on top of that, there will be many more scenarios. So you just need to practice it and explore it, right? And then every day, whatever the commands, like whatever the commands I'm going to execute here, right? These commands, and everything will be captured in a notepad, and then it will be uploaded in the recordings. If you see yesterday, we covered day one demo session. With the day one demo session, whatever the command I executed in my lab, everything will be like captured here. The same way, like today, whatever I captured, all those commands will be uploaded along with the recording. So you can watch that recordings also, right? Right, yeah. Everything will be available. Just need to, practice and then learn it.
Sir, actually, if I have gone through the session, but here we just want to clarify that I'm totally new to this field. So will I be able to follow up?
What you felt so far, like any difficulties or anything?
No, it's not like the difficulty, but the thing is, whoever are posing the queries.
No, I told you, right? Like I'll connect one-to-one with, like, if you are pure new, and then if you know more, like whatever possible, I can cover whatever the basics needed for freshers or the totally newcomers. And
Right,
only thing is you need to practice and you need to ask questions. Okay, what is this? Like I ran ps-ef grep smon, and if you're new, you should ask what is that ps command.
Yes,
And I said
but
cd.
we are
No,
not
like,
getting that type of thought. Like we need to post where to post the questions or like this.
no,
So
we
there
have a
is-
dedicated WhatsApp group for each batch. So once you
Okay.
register for the course, you'll be part of that group, and you can post any simple query. Don't hesitate. Unless if you don't ask question, you'll never learn.
Yes.
Yep.
Like instead means teaching all types of levels. Why don't you create a batch like very beginners to some people are very freshers, and some people have some knowledge and I think some experience also have. So any chance to create 2 batches like that?
That we need to think of. I'm not gone through that because, you know, as I said, it's time and effort.
Because the beginners, you know, they take a bit of time to understand and, you know.
No, like I understand that. Like, you know, that's what, you know, I wanted to make them up to the speed. I'll connect with them one-to-one, and then, you know, I can make them to, you know, catch up the current content, so that, you know, the point advantage is here, you know, rather than a lot of queries and questions, whatever the experts ask, and then, you know, beginners also, they will think through, okay, what exactly that means.
We feel, beginners, they feel, hesitate to ask questions, like, because there are some experienced
No, that's what, like, that is my humble request to everyone.
we feel nervous while asking, you know, basic questions.
No, that's what, like, you know, that is, you know, my humble request to everyone. We never ever hesitate to ask any questions at any moment. Until unless if you don't ask question, you will never learn. Whatever it is, simple, silly, or whatever it is, we have to open up and ask the question. That's the one thing. And the second thing is, as I said, I'll connect with all the beginners, probably on every weekend, Saturday, and then I can cover basic stuffs, and then so that you can up to the speed, right?
Means
And then
11 o'clock you will be available, right? So till what
Yep.
time you are available to?
anytime, like if anytime you can post it. Like again, as I said, we have a dedicated WhatsApp group for each batch, and you can post any questions on that. You know, I'll be available 24/7 there. I'll be responding back on the group. Right, and that's one way. And then still you are not convinced, then I can jump on a Zoom session one-to-one, and then I can clarify on that. So I'll never make them to wait. Try to clarify then and there itself, and then get them going.
Okay.
Yeah.
So once the course is finished, any certificate we can.
You can complete your, you can try for OCA, OCP in 12C, and in 19C you can complete your admin 1 and admin 2. You can try for this OCA and OCP certificates.
So these are all online. We have to
From
apply.
Oracle. Yes, from the Oracle. You have to. There's a payment process for that. You have to make a payment and you have to appear for the exam.
Okay. So will you help on that? Means.
Yeah, this particular course is pretty much enough. Once you
It is
practice,
enough to
and
get
then
those
you can easily.
certifications?
Yeah, that's correct.
So, is there must to be knowledge on SQL and PLSQL also before getting into this Argon DBA?
No, not needed. PLSQL is not needed. SQL basics are needed. It's already, I showed you, like SQL basics are available.
Okay.
If needed, I'm going to cover a few of the basics on that SQL.
Fine.
Yeah.
Because whenever we are writing some queries, like stored procedures or functions, all these are in the PLSQL, right?
Right. 4 procedures, functions, triggers, and all those comes part of your PLSQL.
Yeah. So part of PLSQL is also covered?
No, PLSQL will not be covered here.
Okay, sir. And what is the payment mode that we can pay? So we need to pay?
Yeah, you can ping me on my WhatsApp. I can.
Fine, sir.
Yeah.
Yeah, hi, Malik.
Regarding the
Once again, there's a disturbance. Give me a second, guys. Go ahead.
Yeah, Malik, funny here. See, I mean, if at all I missed or did we cover topic on this DCDR switchover process?
It'll be there part of your DR build activity. We'll be covering building your DR, switchover, failover, and if there's archival or gap between prod and DR, how you can make.
That is the usual thing which we face.
It'll be part of this course. It'll be there in the part of this course.
Okay.
Yeah.
Malik, like if you're given a task to refresh a DB with the size 1 terabyte from source to target in standalone, how will you perform?
Again, like in standalone, you want to restore or you want to build a standalone?
No, in standalone. Source and target both are standalone.
Yeah, there's already part of this course, right? We're going to cover RMAN clone.
Okay.
We're going to cover, there's a various method to build that one. You can use RMAN restore recover. You can use RMAN duplicate with the active database, RMAN duplicate with the backup based duplicate, all will be covered as part of this.
User wants to use data pump.
Data pump means you have to first create your database on the target. Without database, you cannot do it.
Yes.
Yeah, and then export and import will be covered as part of this course. We're going to do that entire database export, schema export, table space export, and then we're going to do that import.
Okay. Should I export the entire database, like, or any specific schema should be exported and import?
Yeah, that will be like covered as part of this course. There's a process.
Okay.
How we can do entire database export and import will be covered in this particular course. Yeah, you can do export, import, you can do arm and duplicate, you can do golden gate, you can build a DR and then do a failover. There are many methods to do that database migration or database cloning. Everything will be like explained.
Would you suggest any parameters for a data pump? Like compression equal to or something?
Again, there's many ways, like, not at this point. I don't want to take it up now because it's an advanced concept. Unless if I take up this course, many people will not be useful here. Yeah, you can do with export import. You can do a database export, entire database export, and you can do by excluding some of the default schemas.
Okay, thank you.
Mike, how can we register for the course over here? For the one starting on Monday, right? This one.
Right. We're going to start it on Monday. Already a few people registered and they're part of the WhatsApp group. And then I'm going to share the Zoom link for them. We're going to use a different Zoom link for the course. And then we're going to continue from the starting from.
Yeah, how can we register? The person who's still not registered, do we need to go? I know you shared certain messages earlier and there is a page where we have the register option. Can we register from there or should I make the payment directly on your number?
Yeah, we can ping me on my WhatsApp number. I can guide you further process, right?
All right, sure.
All right, yeah.
Malik, how can I access your Google Drive, like to access materials and to read some
Again,
of
it will
the
be part.
there?
No, once you register, I'm going to share the further details on the group, on our WhatsApp group for all the registered students. I can guide you how we are going to access, and then what are the links, what are the folders, and which are documents we're going to refer. All will be covered on Monday, only for the students who are registered. I'm going to cover it on Monday. Right, since these are the demo classes publicly available, so I don't want to take that one.
Yes, I've taken all the demo classes.
Yeah. All right, we'll connect on Monday. Once you register, like we connect on Monday, I can explain you that.
Okay, yeah, okay, Malik, thank you.
All right.
Thank you.
All right, guys. Yeah, we'll see you on Monday. Thank you, guys.
Malik, hello. Just last question from my side.
Yeah, please.
So I'm just coming from SQL background, MS SQL background. So I'm a MS SQL DBA right now working on somewhere.
Yeah.
So Malik, if I'm going to take the Oracle, so it will be better, right? There will be no confusion at the time when I'm going to work on MS SQL.
No, absolutely no.
Okay. I'm just thinking that maybe.
No, I am an expert. Like, I know MS SQL. I worked for almost 4 years in MS SQL, and also worked in PostgreSQL, and also worked in MongoDB, right? Those are my secondary skills, but Oracle is my primary skills. There's no confusion queries at the moment. Whichever technology I'm working currently, I'll be strong enough that. Like right now, if you talk about MS SQL, it's been very long, almost 3 years back. The moment I go back again, I may fresh up all the things in one shot, right? So once you learn, then there won't be any confusion. You can correlate. In fact, if you're already working as a MS SQL, you can correlate between each and every concept of MS SQL and then Oracle, and then it'll be in a better position, I can say.
Okay. So actually, Malik, in my environment, it's a kind of financial environment. So I need to work MS SQL and parallelly on Oracle as well. Both databases are there. So it will be no issue, right? To learn the Oracle.
No, that will be great advantages if you're working both the technologies together, because there will be a great chances that, we can upgrade our level to, infrastructure lead, right? Architect lead. Once you do multiple flavors of database, and then only thing is just you need to cope up with the infrastructure stuffs, and then you can become easily architecture level, right? Architecture position.
And
Database architect.
Malik, that in our environment, I need to do some sort of automation in my SQL through PowerShell script. So in this course, I just see some basic things it will guide us, like shell scripting and all those stuff.
Right.
So this will be the stepping stone, right? From that, we can at least proceed further and can create some sort of daily activities, right?
Yeah. That will be
activity.
covered. No doubt in that. It will be covered. I'm gonna share one of the automation script what I written. They can do a lot of automation with a cron job with a shell script, right? Everything will be like covered.
But I just need to know the basic things, Malik, so that we can at least write. Okay. You can get. Okay. Okay. And
Yeah, will be covered. Yeah, definitely will be covered on that automation part. Yeah.
And you will, and we need to install the VMware to set up the VMs and all, or
I can guide you on Monday how to set up the VMs, and there are ready labs, and you can do from the scratch on Monday.
Okay, and my laptop wise, any configuration changes required? At least
We need a minimum of 8 GB RAM.
Achha.
And then if you have SSD, then it's well and good. Otherwise, like it's fine. 8 GB RAM is minimum RAM needed.
And the last point here, last question from my side. Sorry. Here, my in the syllabus, I can see that no DG, data guard or golden gate or rack or rack one. These sort of detailed analysis I am not able to see in that course.
No, golden gate will not be covered. Golden gate is not covered. Data guard is part of this course, right? I said already. Data guard from the scratch. We're going to build the data guard. We're going to do that data guard drill, DR drill activities. Everything will cover. But golden gate is out of this topic.
And rack or rack one basics and.
No, rack one node, rack. It's all the rack portion. It's not a standalone. It's a purely standalone database. Rack one node. Your rack will not be covered here.
At least basic, Malik.
No, that will be there. No, basics will be there. Will be covered.
Okay.
Right. How we covered about track. Okay, I can quickly show you here. This is what we are going to cover. Since you talked on that, if I can share my screen here. Right. So when we talk about database type, right? We'll talk about standalone. What is standalone? We'll talk about Oracle restart, and we'll talk about rack one node, and then we'll talk about what is rack, right? You can see my screen, right?
Yeah. So first of all, my question is that why we going for rack one rather than not rack? Because
right, that's what like we'll cover this as part of this explanation. Right, and then again further more details, rack one node, Oracle restart, and why we are going with rack one node, rack, all will be covered here.
Yeah. Okay.
Yeah.
Okay. Thanks,
Hello,
Malik.
sir.
We need to start from Monday. And what will be the time, Malik?
Same timing. Whatever this 9 AM to 11 AM. Yeah.
9 AM to 11. Oh,
yes.
Okay, sir.
Hello, sir.
Yep.
Yeah. Will you take class for basic Linux tomorrow? Because tomorrow is a Saturday. So as a fresher.
Yeah. Only for the registered candidates.
So
yeah.
So
every Saturday I'll connect with them who are like new and
so from next Saturday you are going to take the classes for the freshers also.
Right.
I think tomorrow there's a basic, so we can learn fast.
Yeah, no, that again, that's not only on the Saturday. I'm ready to take it on weekdays as well. Again, that is subjected to who all are interested, and I'm gonna ask in the group, and then I can send out the link only to them, and then I can cover some of the basics. And then there are some already basics videos available on our Google Drive. I can redirect them to go through them and watch them, so that they can up to the speed.
Okay, sir.
Yep.
Malik, like to find.
There will be no course available for at least weekend as well, right, Malik? For Saturday, Sunday, like this.
No.
Malik, like to find whether the DB is standalone or rack, could we use a parameter cluster underscore database?
That is at your DB level. Once you want to check it at DB level, you have to connect and you have to do show parameter cluster or show parameter cluster underscore database.
Okay.
Whether I'm going to tell you true or false. That is at DB level. And at your OS level, I showed you, right?
SRVCTL config data.
Yeah.
Okay. Thank you.
All right, guys. We'll see you on Monday. Happy learning, guys. Thank you.
Thank you.
Thank you.
Thank you. Thanks a lot.
Bye.